Action. Okay, great. So first of all, we also just want to say welcome and good morning to all of you. And yeah, we're very happy to see that so many of you have joined and want to hear about our project. And now is the time where I'm supposed to tell you the title of our project. But we actually have kind of a problem here. Because we have created a very long title to our project with many fancy words and a lot of technical stuff in it. And we actually liked it pretty much. The problem is just that Carsten, he didn't like it. So one morning we showed up in the accelerator and he had simply changed our title. Yeah. So now we like to the way we like to put it now is that we have a technical title and a commercial title. And I guess today's your lucky day, Carsten, because we have decided to bring the commercial title with us, being unlimited EV range, optimal charging point infrastructure. Yeah. Yeah, you're welcome. And today we will first briefly introduce ourselves. Then we will tell you about the project goal and what our project in general is about. Then we'll take you through our project process and we will talk something about results. And in the end, there'll be time for questions. Great. So, yeah, this is us. First of all, my name is Nanna, and we are both master students at the Technical University of Denmark. And actually, this is our second time in the accelerator, as we also wrote our bachelor thesis here 2 years ago. Yeah, and I'm studying industrial engineering and management.
Yeah, and my name's Kathrine, and I'm studying human-centered artificial intelligence. So, imagine that switching to driving an electric vehicle didn't require any change to your driving behavior as it is right now. And imagine that range anxiety is a term that we could just leave in the past. So with our project, the goal is to include the user perspective to locate charging points such that they are available when and where the electric vehicle users need them. Yeah. So, in our presentation today and in our project in general, the definition of a charging point is one single outlet. So a charging station can hold several stands, which each can have multiple outlets. But one charging point is one outlet. And I hope you've seen the beautiful charging point we've set up down here in the corner, or otherwise it's just on the tour to the metaverse. Yeah. So yeah. The ambition of the Danish government is to have 1 million electric vehicles on the Danish roads by 2030. As of right now, we have 80,000, so that's a significant increase. And the EU recommendation is that for every 10 electric vehicle on the Danish roads, there should be one publicly available charging point. So that means that by 2030, we should have 100,000 charging points in Denmark. Right now we have 7,000, so that means an increase in just about 93,000 charging points in the coming years. The big question is then, where should we locate these 93,000 charging points? The analysis that is done right now to locate the charging points is mostly done on technical factors. So cost-dependent factors, where would the profit be the highest because of traffic flow, and also power grid load and all of these technical stuff. We would like to try to include the user perspective to place all of these to make it better for the electric vehicle drivers. Yeah. To reach the goal of locating these 93,000 charging points and also to say the amount that should be in every location, we've divided our project process into 5 steps or 4 steps and then the results. So we started out by conducting a literature review, and then we went into a data collecting and processing phase. Then we created an algorithm consisting of 2 parts, a meta-heuristic and a mathematical optimization problem. And then the results will be outputted from this. During the literature review, we got an insight into what I briefly mentioned, that right now the analysis of where to place charging points is done purely on technical factors. There's not a lot of focus on which activities the user would like to be present at the charging stations, where they drive from and to, the distances, and all of this. So we found out that there's a need to look more on the users and thereby also the demand. Yeah. To do so, we went out and collected some different data or got access to different data. We here have 4 data sources that is going to be used as the base of data to input into our algorithm. First of all, we created a questionnaire where we got almost 2,000 answers. This questionnaire gave us a great introductory base to the field, and also we got a lot of knowledge on the typical EV user characteristics and how much they drive per week, how much they use public charging stations and subscriptions, and also just their general concerns and preferences. Then we also gained access to a big transportation habit survey done by the DTU, where we have access to almost a bit over 200,000 interviews. And these interviews are about the Danish public's daily transportation habits. So if they go by train, which type of vehicle they go by, where do they travel from and to, what are their primary stay, do they go to work, do they go to shop or go to work out. And then lastly, on the user part of the data, we also got access to some geodemographic and building and housing data containing information on about 3.2 million households in Denmark. So this is both the building type, the geographic placement of the building, what it's utilized for, and also the people in the household. So we also know the location of people with specific educational levels, occupations, ages, and so forth. And all of this combined can be used to extract the data relevant at the geographic locations that should be inputted into the algorithm. Also, we were able to extract data on the current charging points in Denmark. As I told you before, there are 7,000 divided into 1,700 different charging stations. I see there's So we have the geographic location on all of these, as well as the type of the charging point, the amount of plugs, and all of the data needed to be able to take this into consideration when we place the rest of the charging points.
Yes. So as Kat mentioned, we have developed an algorithm consisting of two steps. The first one being a meta-heuristic and the second one being a mathematical optimization model. So when working with mathematical optimization, it should always be seen as a trade-off between execution time and the importance of getting the optimal solution. You of course always want a very short execution time and to get the optimal solution, but it's simply not possible to get both. And especially in our project, we have a pretty strict deadline, so we have to make some decisions here. And that's actually why we are using the meta-heuristic. First of all, as you can see, we have tried to visualize here at least, we have divided into Denmark into squares. So the purpose of our project is to decide how many charging points we should locate within each square. And currently we are testing whether the squares should have a size of 100 or 500 meters. But first of all, I will just tell you a bit about what a meta-heuristic is. I'm not sure if everyone knows, but a meta-heuristic is just a strategy to come up with a good solution where there is no guarantee to get the optimal solution. But you are able to execute it very fast. So what we want with our meta-heuristic is to eliminate squares where we don't consider it beneficial to locate charging points. And in that way we will eliminate half of the squares such that the input for the mathematical optimization model afterwards will be much smaller, and in that way we're able to execute that model faster. And now you might think, what do we then consider a beneficial square? And we'll try to look at that question in a pretty pragmatic way by simply saying that a square is beneficial for the users if it's where the users are. And by that we are looking at, first of all, the employee daytime population such that people are able to charge their cars when they are going to work. And then we're also looking at the nighttime population. However, the nighttime population is not always interesting because it's of course only interesting if people actually have a car. But also we're multiplying the nighttime population with a weight where people living in apartments are weighed higher than people living in houses. And that's because we are looking at public charging stations, as Kat mentioned earlier, and people living in houses are able to put up their own charging point on their property. So therefore people living in apartments are more interesting to us. Great. And then the output from the meta-heuristic is, as I mentioned, the squares that we should put into the mathematical optimization problem. And we have just tried to visualize the results here, where this is for the 100-meter squares and this is for the 500-meter squares, which is why these dots are larger. but all the circles just represents the squares that we are including in our solution. Yeah. And then we have our mathematical optimization model, where we as input use the squares we gained from the meta-heuristic, and also all the data or insights that we gathered from the data process that Kat talked about, which is just about user preferences and behavior and stuff like that. And then we are doing a lot of fun technical stuff. We have created this model. I will not go into detail with that. I think that would bore you a lot, but that's our model. But roughly speaking, there are two things you must consider when making such a model. The first one being what you should optimize, meaning either maximize or minimize, in this case maximize, and then your constraints, which are just some rules that we must comply with. So first of all, what we want to maximize in our project is the benefits for the user, making it as preferable for the user as possible. And we do that by looking at the amount of relevant activities close to the charging point, such that people are able to do things they should do either way while charging. Then we are looking at the typical EV households, because we of course need to place the charging points where the EV users are. And that's also the reason why we are looking at the typical drivers of fossil fuel cars, as we expect that when we get more and more EVs on the Danish roads, people who will drive EVs will be the people who are now driving fossil fuel cars. Then we are looking at the apartment proportion, as I talked about earlier. It's more interesting to us with people living in apartments than people living in houses. And in the end, we are looking at simply where people live and where they are during the day. Then we also set up some constraints. First of all, we have a total number of charging points that must be set up, which is 100,000, as earlier mentioned. Then we are looking at the existing charging points, as we do not expect the Danish government to relocate the current charging points just because we say that they should be placed elsewhere. And then we are looking at the distance between the charging points, such that it's possible for when being at a charging point, it should always be possible to reach another charging point. Yeah. And now we would really have liked to present some results to you. And we actually stayed up pretty late last night to work with it and did a lot of debugging in our code. But we must admit that we couldn't manage to do it. And actually, I was this close to faking some results, but Kat is a better person than me, and she told me we couldn't do it. So we haven't done that. But if you want to see some results, you are more than welcome to come by the accelerator at the end of the week. Then we should have something. Yeah. But what is, however, important for us to highlight is that our method created here, it should be seen as a tool for decision makers, meaning that, for instance, we are only saying how many charging points we suggest there should be in each square. We do not say the precise location, so it should be used as a tool. And also, we don't think that when considering the charging point location, you should only look at the user perspective. We are well aware that, of course, costs and power grid load and profit and so on is very important as well. So we think that our method should be used in combination with other methods to include the perspective of all stakeholders, and thereby making the location most preferable for all stakeholders. Yeah. So now there's time for questions. Yeah. Yes?
How did you come up with the granular scale of half a kilometre?
Sorry?
How did you come up with 500 metres as the granular scale?
In the beginning of our project, we had some consultation with both energy providers and current consulting companies in the area, and they use this as a standard.
They use 500, right?
Yeah, 500
And then we just
meters,
wanted to see if we got better results with 100.
Yeah, and then we're also right now debating whether we should try to make the squares bigger and see if we get something very much different. And so right now we're just debating if we could compare all of these and see which makes the most sense. Yeah.
You explained, Andreas? Yeah, I just thought what if you thought about how the placement of these charging stations may differ from the way that regular gas stations are placed?
We talked with this counseling company who does this, and he actually has been involved in placing Statoil and all of these in the past. And as we understand, at least, there are more technical factors such as traffic flow, and there's also something about how the land is at the places where you should place them, and there's a lot of things going into it. And he was the one saying that we need to involve more of the user knowledge. But we think that our algorithm will place the charging points mostly in cities and towns, whereas right now a lot of the charging points are by the road network.
Yeah.
So that might differ, and that is also why we need to use it in combination, because we need them by the road network as well. But ours will place it mostly where people are, so that will be in the cities.
Yeah.
Yeah.
Yeah, Patrick.
Who's going to use the algorithms? Is there any agreements with those consulting companies?
We are teaming up with Nordlys, so at least they'll get our results. I don't know if they will use them, but yeah.
Yeah. And then the counseling company was also interested in seeing what came of this, to see if they should implement it in their algorithm as well.
Yeah.
Yeah.
As a bonus info, Nordlys has set aside 1 billion Danish kroner to invest in public charging stations, and another 1 billion Danish kroner to invest in private charging stations in the next short time period. So they're super interested. Should we give them a round of applause? Yeah.